You have all the ingredients of a game here. What are the ingredients of a game? In this case, you need to know who the players are. Right? Who are the players here? P1 and P2. You know what are the strategies available to you. Okay? In this case, we are not thinking of strategies, we are thinking of only actions. Okay? They have two actions, confess and not confess. These actions will be converted to strategies if we had people playing sequential games. That is, player 1 chooses first, then player 2 chooses, then player 1 chooses first. So if player 1, if you have a sequence like that, then player 2 could figure out, if player 1 chooses C, then I will choose NC. If he chooses NC, I will choose C. If he chooses C, I will choose C. If he chooses NC, CC, I will choose NC. So player 2 in that case will have 4 strategies. Whereas here, because they are playing simultaneously, we do not have 4 strategies, each player has only 2 actions. But if you make it a sequential game, obviously there will be strategies. Right? So the first thing that we require to know is who are the players. In this case, what are the actions? Otherwise, in general, what are the strategies? Right? Okay. What is the information that each player has? Player 1 knows, player 2, player 1, player 2 know the same thing and they know everything about this game. Right? We know we require to know what is the sequence of play. So whether the game, both the players choose simultaneously or there is an order of play. Fourth, fifth, we need to know what the payoffs are. Right? What the payoffs are. That is, what are the utilities. Sure? Okay. Now we can convert this into what is called a matrix form, a normal form game. Okay. A normal form game will be like this. I'll write the normal form first. So here is P1, here is P2, C NC, C NC. Okay. Now this is what happens if this means that player 1 chooses C and player 2 chooses C. If player 1 chooses C and player 2 chooses C, how much does player 1 get? Both of them choose CC. So player 1 gets 2 and how much does player 2 get? 2. Right? So these are the payoffs. If player 1 gets C and player 2 gets NC, player 2 plays NC, then what are the outcomes of player 1? 4 and 1. Yes, C, NC. Here, 1 4. And if both the players play NC, NC, the outcome is 3 for both players. Right? The outcome is 3 for both the players. Okay? Right? Now, can you predict what will happen in this game? So if you are P1, what would you play? Assuming that you cannot talk to P2, what would you play? If you are P1, what would you play in this game? How would you play this game? Yeah? You are interested in maximizing your own payoff. How will you do that? What will make sure? How will you ensure that that's done? Confess. So what will you do? Yeah, let's argue this. What will you do?
Prisoner P1 will prefer confess because his payoff will be.
Look here.
Two
the
against
critical idea is what you get depends not only on what you do, but what the other player does. So if you play C, and if P2 plays C, how much do you get? 2. If you play C and if P2 plays NC, how much do you get? 4. So by playing C, what you get? You get either 2 or 4. If you play NC and player 2 plays C, what do you get?
1.
If you play NC and if player 2 plays NC, what do you get? 3. So by playing NC, what do you get? 1 or 3. So what you get by playing C is higher than what you get by playing NC, irrespective of what player 2 chooses. Okay? In the language of game theory, C is then called a dominant strategy. That is, by playing C, what you get is better than what you get by playing any other strategy, no matter what your opponents choose, what the other players choose. Right? So what's the dominant strategy? A dominant strategy is a strategy which gives you a higher, at least a higher payoff, okay, fine, than any other strategy, no matter what are the choices exercised by the other participants in the game. Strictly called, properly called, it will be a strictly dominant strategy. If the inequality is strict, if the inequality is a weak inequality, right, that is what you get is greater than or equal to what you get from any other strategy, right, irrespective of what your opponents do, then you have a dominant strategy, or a strictly dominant strategy. So the point here is C is a dominant strategy for player 1. And we will assume that rational players will choose the dominant strategies. Right? We'll assume that rational players will choose dominant strategies. Sure? Okay? Right. So we'll assume that player 1 chooses C. And there's nothing counterintuitive about that. Right? He's choosing one which gives him the best payoff irrespective of what others do. Right? So player 1 will choose C. What do you think will player 2 do? What do you think will player 2 do? Does player 2 have a dominant strategy as well?
Yes.
What is the dominant strategy of player 2?
C.
C. Because by choosing C he gets either 2 or 4. By choosing NC he either gets 1 or 3. So it's a mirror image really. Player 2 is better off choosing C no matter what player 1 does. So we'll assume that player 1 will play C, player 2 will play C, and the equilibrium of the game will be CC. This is called a dominant strategy equilibrium. Okay? Right? So let me pause for a minute and ask you a review question. This review question will help you when you run the videos. What do you mean by a dominant strategy? Okay, that's a review question. So when you run the videos with that question, you have to stop at that question and answer that question for yourself. What do you mean by a dominant strategy? Okay? Second review question is, what is a dominant strategy equilibrium? What is a dominant strategy equilibrium? Okay, fine. So you can clearly see here that CC is a dominant strategy equilibrium. Right? Dominant strategy equilibrium is one solution concept. So ultimately, when you actually, the complete description of the game involves the following. It involves the listing of all the players, the actions or the strategies available to those players, the order of play, the information available to each of those players, the payoffs matrix, the payoffs, and finally a solution concept. A way of solving the game. Right? So dominant strategy equilibrium is one such solution concept. We'll come across many such solution concepts like Nash equilibrium and others. Right? Okay. So we have a dominant strategy equilibrium here. Sure? Is clear? Now, is this dominant strategy equilibrium really the best thing that the two can do? Is the dominant strategy equilibrium the best thing that the two can do, or can the two players actually choose better?
They can choose better.
They can choose better?
They can choose better.
What is the better choice that they can make?
Not confess.
NC. So both of them decide not to confess, then obviously they'll have to be let off after a month in jail. Right? But that is not happening. Why is that not happening?
Because there is uncertainty about what you have to choose.
So let's remove this uncertainty. Okay, suppose on the eve of the decision, so suppose the principal, the inspector, the police inspector tells them that you have to actually make these choices tomorrow. And today evening we'll put you, the two of you, into a room and you can decide and chat with yourself and decide what is it that you're going to choose. Right? Do you think that will help?
It will help.
It will help?
Yes.
So will they be able to coordinate and tell each other that, look here, I'm going to choose NC, you choose NC, so that both of us are better off? Will that work?
No.
Why will that not work?
Because they They will always
decide
think
to
that I
convince
have a
the
better
other
choice
one.
by choosing C and letting
Right.
off.
So
anything.
actually, if you and me, suppose you're prisoner 1 and I'm prisoner 2, and we decide both to choose NC tomorrow, I know that as long as you're going to choose NC, I'm actually better off choosing C.
Yes.
Right? Okay? Because if you choose NC and I choose NC, I get 3, whereas I choose C, I get 4.
Yeah.
And you would know that.
Right.
You would know that, right? You would know that. You would say that even when I'm saying that I'll play NC, I'm actually not going to play NC because it's not in my interest to play NC. Right? The decision is not incentive compatible. Right? And I would know and therefore you would be sure that I would not play NC. That itself should tell me that you are not going to play NC, you're going to play C. And therefore I should play C. Right? Okay? So even when they're allowed to talk with each other, they will not be able to give each other credible commitments to choose NC, right? And they talk to each other, right? That's called cheap talk, right? They talk where people give each other commitments which they don't intend to follow. In the language of game theory, we call it cheap talk, right? So there will be cheap talk, right? But obviously there will not be nobody will have binding commitments, which can be actually enforced, right? So you have CC down. Now you see this outcome CC is actually not Pareto efficient. Why? Because everybody can be made better off by choosing NC. So NC is actually a Pareto improvement. So here you have a situation where individuals who economics. What did it say? That says if you have a market and if you leave things to the market, right? Okay, then obviously you maximize the outcomes are Pareto efficient. Sure? But that's not what's really happening here. So this is an example that the invisible hand does not always work. It is an example of how the invisible hand does not always necessarily work. Right? There is a clear coordination failure. And that coordination failure is very interesting because that coordination failure is not happening because of a lack of commitment. In fact, there is no possible lack of commitment. There cannot be any other equilibrium than this. This is called prisoner's dilemma. Okay, this is called prisoner's dilemma. Right? This is called prisoner's dilemma. And lots of situations in the real world that we encounter actually are examples of prisoner's dilemma. Okay? Take for example your decision. Suppose I want to go to the Fort campus today. I'll go drive in my own car, right? Okay? When I'm driving in my own car to the Fort campus, what am I doing? What is my calculation? My calculation says that I'll actually, use up fuel worth say 400 rupees and say whether what I do there, whether that's going to be worthwhile. That's going to be my calculation, right? But I will never figure in the fact that while driving from Kalina to Churchgate, I'm actually going to spew out a lot of emission. I've got a diesel car and I'm going to spew out a lot of emission. I'm going to impose a social cost. That social cost will never be factored into my individual calculus, right? And therefore, from an individual point of view, when each individual is making a decision which is optimal from his or own point of view, from the society as a whole, we'll have too much driving or too much pollution because nobody is really factoring the fact that driving also imposes this social cost on everybody. Sure? So in fact, if all of us sat down together and coordinated things properly and could succeed in giving each other binding commitments, right? That all of us will use public transport. Then everybody, each of us might perhaps be better off because there will be less congestion on the road and less pollution and so on and so forth. But the point is, as long as all of you are going by public transport, I have all the incentive to drive from Kalina to the Fort campus because I get